Hello everyone. And, I am Udiptya from IIT Madras, and welcome to the course of Research Methodology in Natural Sciences. This is week 5 discussion, and today we will be discussing on these 3 topics: falsifiability, reproducibility, proposing a hypothesis, and elements of scientific measurement. So we kind of touched on some of these aspects, and also on hypothesis, on what is hypothesis, and then we will see some elements of scientific measurement. Yeah. So what is falsification? So by definition, it's the ability of a scientific hypothesis or theory to be proven false through empirical testing. Yeah. So what's the importance of it is it ensures that scientific theories are testable and can be refined based on evidence. Similarly, another aspect is reproducibility in research. Yeah. So by definition, it means that it's the ability of an experiment or study to be repeated by other researchers, yielding consistent results. The importance comes in its that it validates scientific findings and ensures that the experimental design, the experimental study is reliable of the conclusions. Yeah. You see this this triangle. Yeah, there are this similar sounding terms: replicability, reproducibility, and repeatability. In which this is the repeatability essentially means that you as a researcher, you can repeat the experiment maybe some n number of times and get consistent data. Then comes reproducibility, in which some new researcher also reproduce that experiment with same experimental setup and get the same data. And then comes the replicability, yeah, in which you go for new researcher and you go for new data. Yeah. You can replicate the system. So that's the 3 triangles of this research study. Yeah. So we'll go for the problems now. Yeah. So a researcher uses an experimental design to study the effect of music on memory. In this experiment, the independent variable is so you all can write in the chat and also maybe speak up also. It's okay.
And this independent variable is music.
Okay. Can you define what is independent variable and dependent variable?
Independent, which brings changes.
Okay.
On dependent variable.
Okay.
Suppose if we do some procedure, for example, I do some tepid warm water therapy. That is independent variable that brings changes in the temperature.
Okay. some people in. Yeah. Okay. Okay. Cool. Others are not. Yeah. So whoever has joined now, we are discussing a question on independent and dependent variables. So a researcher uses an experimental design to study the effect of music on memory. So you all have to tell which one of them is the independent variable. So as you told, yeah, the independent so we have two kind of variable, yeah. One is independent, and then there is dependent variables. So independent variable, it's the cause, yeah. It's the cause, and while the dependent variable is the effect. So so the independent, why it is independent? Its value is independent of other variables in your study. Okay, this is independent. That's what it is means. But the dependent variable, the value of dependent variable will be will depend on the changes on the independent variable. So it is dependent on the independent variable. So in experiments, what we do is we manipulate the independent variable usually. Okay, we'll vary this. We'll vary the independent variable and get the dependent effect out of it. So by this explanation, now I think it makes more sense, yeah. So now I think people can write the answers here in the chat. So the answer here is music, yeah, A. So this will be the answer. Okay. So yeah, that's the problem too. Yeah, in an experiment, the researcher manipulates dash variable and measure the dash variable.
Manipulate the independent variable and measure the dependent variable.
So as we discussed in the last question, the answer is independent. Here independent, and here dependent variable. Yeah. Aside from repeating experiments, what other factors contribute to the reproducibility of the scientific results?
The involvement of different scientists in each repetition.
Yeah. So repetitive stability essentially means that other scientists can also uh, replicate or get the similar results when they do the experiment. So this is the fourth question. How does the criterion of falsifiability contribute to the self-correcting nature of scientific inquiry? It discourages scientists from challenging established theories. It promotes the acceptance of untested hypotheses. It allows theories to remain unchallenged indefinitely. It encourages the continual refinement and improvement of scientific theories.
It encourages the continual refinement and improvement of scientific theories.
Okay. Yeah. So that's what falsifiability is, yeah. That we discussed. How does a postulate differ from a theory in the scientific context?
The question answer is not visible.
Huh? What is not visible?
Question number third and fourth.
Yeah. We are at 5.
The screen will be not visible now.
Is it? Is it all, for all or?
Question number third and fourth, miss it.
Oh, you missed it, yeah?
Yeah.
Actually, anyway, I will put the recording, so maybe from there you
What?
can. I will anyway put the recording for the class.
Okay.
Okay. So the answer here is A. Most of you have told. So can anyone explain what is the difference like broadly as such?
It is like postulate is like assumption. That whereas theory is it is developed on.
So postulate is assumption, and then theory is a.
So the issue is that the screen is not visible.
I think it's issue from your end.
What's up?
I think it's an issue from your end. Because for others also it's visible.
Okay, I'll check it.
Yeah. So and for theory it is a proven statement, yeah, proven mathematical statement. And this is assumed. It is assumed to be assumption is just true, yeah. But then you have to prove the theorem. So Yeah, that's a well, that's what it is. That means the well established means, yeah. It has a mathematical proof essentially. In a standard normal distribution, what is the mean and standard deviation? So I think in the scientific measurements part, you all have read about normal distribution.
I think it is D.
Okay. Okay. Can somebody explain their answers also? So how does a normal distribution curve looks like? Yeah, the normal distribution have this kind of bell-shaped curve, yeah. So its center is answers, please. Answers, anybody? So, in standard normal distribution, usually this is the origin, yeah, 0, 0. So the mean is considered to be the middle point, yeah. This is the new. So in a standard normal distribution in which it is at the origin, nu is, or the mean is equal to 0, and the standard deviation is basically determines uh, the width of the curve is essentially the standard deviation, and it is considered to be 1. So this side 0.5, then this side 0.5. So the answer is mean equal to 0 and standard deviation equal to 1. Yeah. The spread, so the mean basically tells where the center is, center of the curve. The standard deviation basically says the spread. The empirical rule states that approximately what percentage of data falls within 2 standard deviations of the mean in a normal distribution. So kind of a continuation question.
Yeah. 68%.
Okay.
$800. 95%.
Okay. Can anybody explain what's this empirical rule all about? No? So, if this is the curve. So this rule is this empirical rule is essentially 68, 95, 99.7 rule. So this is also known as this. So in this, if you consider this to be nu, we can consider here nu plus sigma, here nu plus 2 sigma, and here nu plus 3 sigma. Similarly here nu minus sigma, nu minus 2 sigma, and here nu minus 3 sigma. Yeah. So we say that in this region you have around 34.1 34.1 34.1 data, 31.1% and 31.4%. That means 68%. Yeah, in this region, in one standard deviation basically. And then it comes to this region, nu minus 2 sigma to nu plus 2 sigma. Here we have around 13.6% data. Which together makes 95%. Then in this, the other region, there we have around 2.1% data, which basically if you add, it gets to the 99.7% data. So we should consider that with at nu minus nu, when it is 3 sigma, when we take, it's almost we have covered all the data points, because it's tending to 100%, but it will never be 100%. Yeah, that's the nature of standard deviation, and that's the nature of normal distribution. Sorry, so the answer here will be 95%. Yeah. So this is a problem question. In an investigation on neonatal blood pressure in relation to maturity, for the following results were obtained. The question is somewhat complex. Just let me see. So what it is given is there is neonatal blood pressure. Okay, so we have to tell whether this is there any difference in mean systolic pressure in babies, normal babies, and in neonatal asphyxia. So for your first being it's in the first question, I will define the null hypothesis. Null hypothesis, there is no difference in systolic blood pressure in normal and neonatal asphyxia babies. And then alternative hypothesis is there is significant difference. So you have to tell whether there is significant or not significant difference. Yeah. So take your time. Yeah. you guys are trying, yeah? Okay, should I solve it or you all are trying? Okay, maybe you can see it, yeah, for now. So what we can do, this is a question of normal distribution in which we can calculate the z value, yeah. Z value is essentially x1 minus x2, which is the mean, and we take the so here everything is written. Mean systolic pressure, this is the mean of the two groups, and this is the standard deviation. This is the number of number basically. So what we'll do is 75 minus 69 divided by 36 by 54 plus 25 by 40. So it comes out to be minus 16, 69 is 6. So have to calculate. It comes out to be 6.566. 3.8314. Now what you have to do is you have to check this z value in the table, yeah. I hope you all have done this, yeah. So for 95%, okay. For maybe maybe you all have not seen the z value chart and all, yeah. So okay. So that's the how you calculate the z value. That's okay. Maybe you can leave it till here. Not the hypothesis testing in which we can test the hypothesis. Maybe that's that you have not done. Maybe. That's why I don't see much people solving it. Okay. Anyway. This is a similar question. The operations manager of a large production plant would like to estimate the average amount of time workers takes to assemble a new electronic component. After observing the number of workers assembling similar devices, the manager guesses the standard deviation is 6 minutes. So you have to tell how large a sample of workers should be taken if the manager wishes to estimate the mean assembly time within 10 seconds. Assume that the confidence level is 90%. Would the answer change if the confidence level is 99%? So we have given the Z values already. Okay, so we will write whatever we have the information on. Yeah. So first part we will write it. First part of the question, this one. So standard deviation is given as 1/6 minutes here. Deviation is 6 minutes, and mean is 10 seconds. 10 second means 1/6 minutes. So again making z is x minus m by c. So for 90%, so assuming confidence level of 90%, the z value has been given as 1.645. Yeah. So here it will be 1/6 by 6 pi root n. We have to find the value of n. So n will be 36 into 1.645 square. Okay. So you have to see what it is. So it will be around 3507. Yeah. This is the number of workers that should be taken if the manager wishes to estimate the mean assembly time of within 10 seconds. So this is the answer. Yeah. So second part, would the answer change if the confidence level is increased? It's 99%. So if we increase the confidence level to 99%, z value will be 2.575. Yeah. So similarly, putting it in this formula, then the n value will be n equal to 36. Only we have to change this value. Yeah. This is basically the z square into 2.575 whole square. So the answer is 8593. So the difference, so when we go from 90 to 99% of confidence interval, what we get is we essentially, so basically we gotta write 8593 minus 3507. Yeah, that's the difference when you go for the confidence, and we get a difference of 5086. Yeah. So it's usually it does change, yeah, depending on the number of what is the confidence level. Yeah.
Sir, what about 10 seconds? 10 seconds I have not used anywhere.
Oh, 10 seconds I have converted it to minutes actually. This one.
Okay. Oh, okay.
So I think from the next classes there will be more of numericals. I think numericals are a bit tough. I know, tougher than the theoretical ones. So for today I kept it low. For today I kept it actually less number, but I think for the next one, when we have hypothesis testing and all, and I would like you all to learn how to see the charts, the normal table, the normal distribution table, and t-test table and all, so that you know how to read all those tables, because then in here most of the times the z values will be given, but sometimes it may not be given, so there it will be an issue actually. Is this question clear, or should I explain it?
So I have one more doubt, sir.
Yeah.
Sir, what about x minus mu? Actually, mu is 1 by 6. What about x, sir, here?
So it's a difference between the from the mean position. So where do you have the mean given, you can directly put it there.
Okay, sir. Sir, in case if z value is not given, shall we use the table in the examination,
Yeah,
sir?
you have to take the table values.
Okay, sir.
Okay then. We'll keep today's class till this then. If anybody has doubt, they can ask.